Alright, we're about to get in the river, so get on your waders. Get your river clothes on. What do we got? We got Jim's boat can travel 10 miles down the Arkansas River. In the same time, it can travel 6 miles up the river. If the speed of the current is 3 miles per hour, what is the speed of Jim's boat in still water? Okay, so this is what we're going to be using. Distance is equal to rate times time. Rate times time. What we're going to, sorry for the delay there. Alright, let's look at going down the river. So we're going to go, well, I'm not sure. You know what, we'll do this. We're going to go down, we're going to go down the river. So let's write this out. What is D going downriver? 10 miles. What is the rate going down the river? We don't know what the true rate is. Remember, we're trying to figure it out in still water. But we know that the rate in still water plus 3 miles per hour. Okay, because that's the rate of the current. Times T. We don't know anything about T other than he can travel 10 miles down. At the same time, he can travel 6 miles up the river. You see that? Now, let's write an equation for going up the river. Up the river. So this time, he's going 6 miles up the river. We don't know what the actual rate of the boat is if it were traveling in still water. But we know this much. He's going up the river, so whatever it is, he's going to subtract off 3. See? Subtract off 3 because he's fighting the current. He's going up the river. T, we don't know. We just know that it takes the same amount of time going 10 miles down the river as it does going 6 miles up the river. So what we've got here, 2 equations, 2 unknowns, but the thing about this is we can set both of these equal to each other if we rewrite them. And we're going to do that. So this one here can actually be rewritten as T is equal to 10 over x plus 3. See that T is equal to, this is going down the river. Alright, we'll label that error as going down. Let's go ahead and write this one over here. So this is T going up the river. Okay, that'll be this equation here. And that's 6 over x minus 3. X minus 3. Okay. Well, since both of these t's are the same, we can just set both these equations equal to each other. we'll do that. 10 over x plus 3 is equal to 6 over x minus 3. X minus 3. Now we have an equation where we can solve for x. Best thing, quickest thing to do here, just you're multiplying both sides by x minus 3, or think of it as diagonally taking it up here to the top, and then multiply both sides by x plus 3, but you can think of it as taking it diagonally up in this direction. So let's go ahead and rewrite this. So we have 10. Well, don't mean to write it in that color. Well, what's going on here? We have 10 times x minus 3 is equal to 6 times x plus 3. Okay, then we just solve for x in this problem. Distribute that 10 across, so we have 10x minus 30 is equal to 6x plus 18. Now, since 10 is greater than 6, let's go ahead and take this over here to this direction, and we'll take the 30 over here to this side. So we have 10x minus 6x is equal to 30 plus 18. We'll go ahead now and add 10 minus 6 gives us 4x, and 30 plus 18 is 30, 48, 48. X is equal to 48 over 4, and of course we want to try to simplify that down as much as possible, maybe even get a decimal if we have to. Well, actually that's 12. So what is 12 in units? Miles per hour. Okay, miles per hour, 12 miles per hour. That's how fast the boat would be traveling in still water. Okay, but is 12 miles per hour. So you can look at this as 12 plus 3 is 15. Right? He was going 15 miles per hour down the river. You see that? And then 12 minus 3 is going to be, what is that, 9. 12 minus 3, he was going 9 miles per hour up the river. Yep. But I guess the question is, see now once we know that, you can come in here and solve for t if you wanted to. You can figure out how much time it took for him to go down the river, how much time for him to take that it took to go up the river, if you had to. Right? Okay, that's an interesting problem. And I shall see you in the next one.